All right. So I think some of these first ones are going to kind of make sense. And then we're going to do something called rationalizing, but we're not there yet. That's for Math 3, Honors Math 3, yeah. It's the unit where lots of puppies die, so I'm keeping it front and center so that they will not kill them. I showed them how puppies are killed, and then they immediately tried to kill one, and I was like, okay, that's a great example of what not to do. So, okay. It was completely on accident, which was the concerning part. I said, here's how you kill a puppy, and they went, yeah, and they stabbed it. And I was like, whoa, that's very concerning, you know. Whew, yeah, we take the knife, we put it down, you know. All right, so when we see division problems that are written like this, anything that does not have a radical gets to be divided. Anything that has the same type of radical also gets to be divided. So here we have a 12 and a 2. What do you get when you divide those? You get a 6. And then we have a 160 and a 5, and those are underneath the radical. So we're going to divide those, and we're also going to put that number underneath a radical. So what's 160 divided by 5? 32. Okay. Is 32 a perfect square? No? Okay. So let's break it down then. 32 is what times what? 8 times 4. Okay. How do we break down those numbers? 2 and 2, 4 and 2, and then 4 is 2 and 2. Okay, so we've got a pair, and we've got a pair, and we've got a leftover. So our final answer for this is 4 times 6, yep, is 24. Square root 2. Okay, cool. And if we wanted to like check and see if this was, you know, accurate or at least not horribly wrong, we could type 12 square root 160 divided by 2 square root 5 and just make sure that that's the same decimal as 24 square root 2. And it's the same decimal, so at least we didn't screw anything up too badly. So, cool. Okay. Let's try another one like this. This one's going to look real crazy, you guys. The place I got examples from, they did real big numbers. And I was like, whoa, this one looks scary. Yeah, 1,250. Quabam. Okay. So if we do this one, what do we get? Okay, 36 divided by 9 is 4. And then 4 through. This divides evenly. I mean, it should divide in 2. What do we get? 625. Okay. Is 625 a perfect quadruple? I don't know. I don't know my quadruples. Okay, let's break it down. 125 times 5. Okay. Five and 25. 5 and 5. Ooh. It is a perfect quadruple. Okay. So we have no leftovers. This was a perfect quadruple. The fourth root of 625 is 5. And so we're going to do 4 times 5 is 20. That's your answer. Yeah, there's no radical left because we had no singletons left.
So the little 4 just means like how to carry.
Yep, you're looking for 4 sets of 4 instead of sets of 3 or sets of 2. Yeah. So up here we had a square root, which is why we looked for pairs. Okay. Let's try. Ooh, I know how this one's gonna go. Oh, I'll do this one first. This one is. I'm gonna do this one because I think you guys will want to stab me a little bit less if we do this one first. I'm putting a letter in there, but it's just like a little bit of a letter, you know? It's not like a terrible amount of letters. Okay. It's not too many letters, it's just a little bit. So, okay, 28 divided by 4 is 7. That wasn't so bad. What do we do because we had this negative? We bring it to the front. Okay, it's going to go with the 7. Okay. 16 divided by 2 is 8. Okay. What happens with the m's? Yeah, you subtract the exponents. So we're going to have m to the 5th power. So if there were 6 m's on top and 1 m on bottom, one of the m's on bottom would cancel with one of the m's on top, and we would have 5 left over. Does that seem reasonable? Make sense? Okay. Can we simplify anything about this? Is 8 a perfect cube? Yeah. What's the cube root of 8? It's 2. Okay, so we're going to say that this is just going to be a regular 2, and the regular 2 is going to hang out with the 7. So 7 times 2. We're going to have that in the front. But with the m to the 5th, I'm just going to write this out 5 times. 3, 4, 5. Okay. How many should I circle? 3. I have one group of 3. Mm-hmm. Uh-huh. Yeah, if you're fancy. Yeah, that's fine. Okay. So in the front we have negative 14 and m, and then we have cube root of m squared. Okay. Are we good? Okay. Okay, now I'm going to give you one with some more letters. Can we handle some more letters? Sure? Yes? Yes? Okay. With this one, we're going to do cube root. X to the 3rd, y to the 9th, over cube root x to the 2nd, y to the 5th. Whew. Okay. It's going to be x to the what? Okay, so x to the 1, right? That's why you're saying just x? Uh-huh. I was just interpreting for people who may not have got that. Not working so fast. Okay. And then y to the 4th. Okay.
Is that the one you said that we was going to stab you on?
Yeah, if we hadn't done the previous problem, you might have stabbed me. That's a lot of letters. It's a lot of letters if we didn't ease our way into it. That's easier than this one? But just the letter part? This letter part?
No, I'm not.
This letter part eased us into this letter part.
I'm saying, like, if you explained it the same way as you did the one before,
Oh, you guys are, it would have been fine. Okay. All right, and then we still got to fix it because it's got y to the fourth inside, which can be reduced a little bit. So how are we going to rewrite it by fixing the y's? And we got a lonely little x there, so that's not going to go anywhere. It's a singleton and a singleton. So, okay, so what are we going to do? We're going to have a y on the outside because of this. And then we're going to have a cube root. And what goes in the cube root? xy. Okay. Yeah. Yeah, don't we love those? Aren't they so fun? Okay. Let's look at some. Did you say, can you shut up disrespectfully?
And I told him shut up respectfully.
Wow.
That's like the disrespect.
Completely opposite, so you have black and white kind of. What?
All right, let's look at this one and let's see what's going to happen with this one. This one's going to get a little weird. Okay. 7x to the fifth, cube root of 7x to the fifth over cube root of 64 y to the sixth. So if we look at this one, can we divide the numbers?
No, I mean, you realize it's 109,375.
7 over 64?
Can't you just like
Yeah, so if we can't actually divide them, then what we should do is just try to simplify them separately. That's what we're going to try to do. So let's pretend this is two different math problems. So let's look at just the top. Are we going to be able to simplify the 7? No. Okay, but the x to the fifth, I can do something with the x to the fifth. 1x with some leftovers. So what is the top going to look like?
X on the outside. Yeah.
X on the outside, okay, and then what's on the inside? 7x squared. Okay.
why is there an X on the outside?
Because there was a triple. Okay. All right, and then if we look at the bottom as a completely different problem, is 64 a perfect cube? Yes? No? Yes? It's 8 to the third? So we have to think, we can't say 8 to the second is a perfect cube. 8 times 8 is 64, I know, but we're not doing squares, we're doing cubes. 4 to the third is 64? Okay, let's all check our calculators and just make sure 4 to the third is 64. To type that in, we're going to use this little button, they call it a caret.
And 4 times 4 is 8, and 8 times 4 is 8.
4 to the third is 64. Okay, so the cube root of 64 is 4. Okay. The y's, we're going to write out 6 of them. And what happens? 2 sets of triples, no leftovers. Okay, so what is this going to give us? Y squared. Okay, so that means that this whole thing was a perfect triple, no leftovers. That means no radical on the bottom. Okay, so over here, yep, I'm going to say 4y squared. Okay. Okay, now I'm going to show you what can happen when you're dividing and there's something that is a little problematic. Okay, you guys ready for what could be problematic? Okay. All right, we're going to have square root 9 over 2 square root 5. Okay, so clearly we know you can't do 9 divided by 5. That doesn't give you a whole number, right? Okay, so we're gonna simplify them separately. So on the top, can you square root 9?
Yes.
Yeah, what do you get? 3. Okay. So on the top, we get a 3. On the bottom, can you square root 5? Can you break it down? No. So it's already as simple as it gets. Now, this is considered to be not proper. This is like if you walked around calling your teachers by their first name. Not supposed to do that at all. Like, not okay. Whew. I've had students start emails to me that say, "Dear Miss Catherine," and it makes me want to punch them in the face. I'll be honest. So don't. I did have somebody write an email to me and it said, "Dear Mr. Rice," and that also made me want to punch them in the face. So, there was a lot of confusion in the email, so I'm not sure if they just didn't understand the difference between like Mr. and Miss. I'm not sure. It's Ms. It's Ms. Miss. So Miss, M-I-S-S, is like I'm young and unmarried. M-S is we're not sure what we know if we know what it is. Yeah, so M-S is could be Mrs., could be Miss. Typically, you would use that for older women who are maybe single as a sign of respect. Like, I'm not calling you an old maid. I'm just being nice. But MRS, you can say MS as well. So you can say Ms. Honeycutt. That's fine. Here's the reason. Men made it complicated. Listen to me. Men made it complicated, and here's why. Because if you're unmarried as a man, it's no big deal. But culture has made unmarried as a woman an issue. And that's why all these pre-whatever matter, because women care if they're married or not. I don't... I'm an MISS. I'm a miss, and because I'm on the younger side and I don't care. Yeah.
But could I say
It's an engagement ring.
No, she said that was a ring.
I'm a miss. 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 I'm on the younger side and I'm not married and I'm not ashamed of it. So we are good. Yes. Yes.
When are you getting married? So not
MRS.
Miss.
Future, so
Last name King?
King.
presently not.
Yep, you're going to have to call me something else.
When is King?
In 2 weeks.
That's really?
Yeah.
Can we go?
You cannot go. Literally no one's invited. My mom's not invited.
What?
No one's invited.
We're not. Wait,
Is it one of those kind of like,
down on the low.
It's not down on the low. We're just not inviting anyone. It's not run. So yes, that's exactly what we're doing.
Wait, actually? Wait, so is it like nobody's gonna be there? And the preacher.
You can't have nobody there because you have to have witnesses.
Yeah.
But
Like I meant like
I don't know who the witnesses are because we said, hey, can you get witnesses because we're not inviting anyone? And they said, sure, we'll do that.
Like you don't even have like a maid of honor.
No. Because no one needs to be there. Well, I'm from Oregon, and all my closest friends are in Oregon. So
hey, you're in the South, you should have shot. Go down to like a...
I'm not going to the courthouse. I'm getting married at a waterfall.
I was going to say, you're in the South, you should probably go like...
But not, because they were on like the ferry boat thing. Yeah. Yeah. I have to like go on a hike and climb down rocks. I'm gonna wear tennis shoes. It's gonna be fine.
You're gonna look so good.
Thank you.
And what?
I was going to say, you're in the South, you should have a shot. Wait, like, go down...
That's what I have.
Go down to like the next 7
Wedding dress?
Mm-hmm.
Some
You're like,
my mom got married in a shirt and jeans. Yeah.
Yeah. All right. So like I said, this is like calling a teacher by their first name. We can't do that. We have to call the teacher by their last name because that's proper. So we fix this. It's called rationalizing the denominator. We're going to write that down so we don't forget what that is. This is rationalizing the denominator. Rationalizing the denominator. That's what we're going to do right now. Yeah.
I don't get how Garen's so not.
yeah. Oh my goodness, you should see him in Spanish.
So we're going to multiply it. We're going to multiply this by 1, but it's not going to look like the number 1. We're going to multiply this by 1, but it's not going to look like 1. We're going to multiply this by root 5 over root 5. Now, when you multiply this by 1, the one that you multiply it by is going to look different every time. It's going to depend on the problem. But it is 1. I'll show you. If you do square root 5
Is there,
divided by square root 5,
is there,
that's 1.
is there an animal for simple addition and subtraction? Because you might want to get on here about that.
Maybe.
You couldn't do 21
So-
minus 19.
I didn't know what you were talking about.
So listen carefully. We're
I know.
listen carefully. We're multiplying by root 5 over root 5, which is 1. So if we're multiplying by 1, this is still going to equal the same number. It's just going to look different. Does that make sense? It's going to equal the same number. It's just going to look different. Okay. So on the top, I'm going to have 3 times root 5, which is just 3 times root 5. On the bottom, I have 2. And what is root 5 times root 5? But with a root over it, right? Root 25. What is root 25? 5. It was a typo. That's what you meant. So we have 2 times 5, which is 10. 2 times 5 is 10.
Why'd you put the 5, square root of 5 divided by square root of 5? Because of the 2 times the square root of 5?
So this here was improper. This is like if you guys were to all call me Catherine, like we were buds. That's weird. And this is like you're calling me Miss Rice.
So you just split the 2 times 5 things.
So we fixed it.
So it's okay, like,
This is okay.
where it has a square but not denominator.
Yep, you can have a square root in the numerator, but you're not supposed to have a square root in the denominator. So this is proper. This is like math slang. It's sloppy. It's you can do it when you're in upper level math and you're really good at math and people are like, they're so good they don't feel like fixing it. They're super, super smart. But you get to do this in college after you've made it like to calculus and beyond. But before that they go like, please fix it. You have to prove you can do it just so you can slack off. And actually, this is actually pretty common. You'll get to college courses, I'm not kidding, you'll get to college courses where professors will go back to letting you call them by their first names. And it will not be considered disrespectful.
If it's accepted in the first place, what's the difference?
It's knowing how to make something proper. So that you're showing that you understand how something works, and then you can go back to like, okay, but now think about it this way. Math professors write mathematical textbooks. Those are the people who write the textbooks. They can make it even more perfect than this. So if they want to write in slang, sometimes we let them. But then if they need to go and write something really professional, they can also do that.
They try to be my life.
Yeah. Yes.
So can we just like do the 5 times 2 and say it's 10, or is this just a coincidence?
If you want to skip over and say it's 10, that's fine.
So it's not a coincidence, it works fine?
And move the 5 to the top, yeah.
Okay.
So there are a lot of students who don't show all this work. So we typically, what we do is we show the work in the beginning until we get comfortable with it, and then if you want to stop showing the work, that's fine.
So in math 3, you're not going to get mad if you don't show.
I'm not going to get mad on this if you don't show the work.
So we can leave it at 2 over, or 3 over.
No, you can't leave it at this. Don't call me by my first name. You got to write it like this, but if you don't want to show the in-between steps, that's fine.
What?
Calculus. I'm not going to lie, I don't like math too. It's boring. Okay, let's...
So that's all you have to do? You don't have to go through.
Isn't it cute? It's cute. All right. Yeah. Yeah. All right, let's try another one of these. All right, we're going to do square root 8 over square root 15. Now, can 8 divide by 15? No. So, we're going to have to fix this one. I know, this is improper. Don't call me by my first name. Can't do that. So, we're going to multiply. We're not friends. I'm not going to go to the movies with you guys. That's weird. Don't call me by my first name. No. All right, so what are we going to multiply this by?
15.
So we're going to do what on top, what on bottom?
15 squared on the bottom.
Yeah, root 15 over root 15. It's just whatever the root is. That's what we're going to do. Root 15 over root 15. You would not, because the root 8 is not the problem.
The 15 is.
The 15 is. So you do whichever root is the issue. That's it's the one on the bottom.
It is always.
It says always at the bottom.
Yeah. Yeah. All right. So on the bottom we have root. What is 15 times 15?
Oh.
225. Okay. So on the bottom we have root 225. And then what's the square root of 225?
25.
15. Okay. It's 15. So on the bottom we have 15. And then on the top we have 8 times 15.
I'm sorry, but is that always going to be the same?
Uh-huh. Uh-huh.
120.
We have 120? Root 120. Okay.
So this is the first name thing.
Uh-huh. Uh-huh. This is, you call me by my first name, don't do that. Call me by my last name, that's proper. We can't divide these because one is under a radical, one is not under a radical, but we should take this number under the radical and we should reduce it.
By 15.
Not by 15. We're going to take it and we're going to say, all right, 120. We're going to do our little factor tree. 10 and 12. 6 and 2.
I thought you guys finished something you wanted to.
Yeah.
3 and 2. What else do we have?
What was Jezzer?
5 and 2.
5 and 2. Okay. So we got to look at our pairs. We got to look at our leftovers.
It's 5 and 5, 2, and 3.
Okay. Single, single, single. Okay. So what goes on the top and what goes inside? Or what goes in? Yeah, what goes in the front? What goes inside? 2 goes in the front. What goes inside?
11.
We don't add them. We multiply them. 30. Okay. And 15 is on the bottom. Now I can't touch the 30 and the radical, but if I look at the plain numbers, the 2 and the 15, if those could reduce, I would reduce them.
But they can't.
They can't reduce, so I'm done. Okay, so here's what I think that I'm going to do, because we're getting towards, I don't know, we got 20 minutes. I think what I'm going to do is have you guys practice the ones that were like this, where they go in evenly.
Yeah, I prefer to call people by their last names. I'm sorry.
What day are you getting married?
Pi Day.
So
Do
March
we know what Pi Day is?
March
Not 16th.
Oh, 3.14.
3.14.
March 14th.
Oh, I thought it was 3.13.
What's going